Magnetic field due to a current through a straight conductor. Set up the apparatus as shown here. Sprinkle some iron fillings uniformly on the cardboard. Keep the variable of the rheostat at a fixed position and note the current through the ammeter. Close the key so that a current flows through the wire. Ensure that the copper wire placed between the points X and Y remains vertically straight, and observe the pattern of the iron fillings. You would find that iron fillings align themselves, showing a pattern of concentric circles around the copper wire. What do these concentric circles represent? They represent the magnetic field lines. How can the direction of magnetic field be found? Place a compass at a point, say P, over a circle. Observe the direction of the needle. The direction of the current is from north to south. The deflection of the magnetic needle is towards the east. The direction of the current is from south to north. The deflection of the needle is towards the west. In this activity, we find that the deflection in the needle also changes. In fact, if the current is increased, the deflection also increases. It indicates the magnitude of the magnetic field produced at a given point increases as the current through the wire increases. Now, place the compass at a farther point from the conducting wire. You can see the deflection in the needle decreases. Thus, the magnetic field produced by a given current in the conductor decreases as the distance from it increases.